Here's some sample problems with that involve friction. So if you have a horizontal track and there's a cart on it and it's being given a push, so here's that force of the push. The mass of the cart is given as 500 kilograms with the initial velocity of 17 meters per second and a final velocity of 0 when it comes to a stop. We know that it has a coefficient of friction of 0.8. This position is going to be 0, where this position is going to be 100 meters, giving you a displacement of 100 meters. And you're trying to find this force. And you don't know anything else except that you know that it's coming to a stop, so you're decreasing speed. I'm going to say this is my line of action. That's positive direction. And then I can draw my free body diagram, which means my force of my push is this way, my normal force is that way. Gravity down, force of friction opposes the motion. So that's my free body diagram. I always start with what I'm looking for. I know I'm looking for the force, which is on the x-axis, so I'm going to start by writing out my x-axis equation. So in order to solve for this unknown, I need my friction force. The only way to solve for friction force that I know of is using the friction equation. And we know what mu is, but we don't know what normal is. So in order to find normal force is on the y-axis. So I'm going to write out my y-axis equation, and I'm going to write Fn minus Fg equals may. It's not moving up and down this way, so I know that Fn equals Fg, and that's mass of the cart times gravity. So if I put that in for here, I've got mu mg. So now I've got my force of friction, so that goes in there. So I can write it. And now I need to write out what the acceleration is. So how do I find acceleration? Well, that's kinematic. So Vi I know, V final I know, acceleration is what I need. Distance I know is 100, time I don't know, nor do I need it. The equation that has those 4 things in it is this one. And so if I know that final velocity is 0, then I can get an expression for acceleration that's negative v initial squared over 2d. So I can put that in for acceleration. So this force is mu minus mu mg equals mass times negative v initial squared over 2d. Now I'm leaving all my variables in because that's often what you're being asked to do on the AP exam, and we should get used to doing it this way. It also enables you to answer questions like what happens when the mass increases, what happens when coefficient of friction increases, what happens if you lower the initial velocity. You know, those will enable you to figure out those relationships. You could make graphs from this information as well. But since they asked for an actual answer, we can plug in the given information, and then you just have to plug it into your calculator. And so you get 500 times 17 squared divided by 200. This part here, I'm going to squish over here, 722.5, and 0.5 times 500 times 9.8. Oh, sorry, 0.8 times that is 3920, and this is negative. So you end up with, so squished, 3197.5 newtons, and that's your answer. Sorry about that squishing. All right, let's do the next one. Small block is given initial speed up a ramp. So here's my ramp. It's given an initial push, so now it has some initial velocity in the positive direction. We know we have a coefficient of friction. They want us to find that coefficient of friction. We know up at the top of the ramp it comes to rest, right? That's greater than 0. We know the distance over which it travels, we're calling d, and this is mass m. We have no numbers here. This is theta. When I draw my free body diagram, I've got normal, I've got gravity, and I've got friction force. The force with the pushing force is not given and not needed because it already has that initial speed. So when I look at this and my line of action is up the incline, right? This is my line of action. So I'm going to break this into components. I'm going to have Fg sub y and Fg sub x here. And my angle of my incline is in there, right? Inside of here. So, so now I also want to write my motion diagram. There's my velocity and it's slowing down. So it goes velocity, acceleration is negative. So I need to find the coefficient of friction. That's the friction force over the normal force. So in order to find the coefficient of friction, I need to find both the friction force and the normal force. So that's what I'm going to do. So I'm going to use the x-axis equation to find the friction force. So it's negative FF minus FGX equals MAX. So negative FF equals M. I added this to the other side, mg, and this is going to be opposite, right? The x component is opposite the angle, so it's sine theta plus max. But I don't know what acceleration is, so I need to get a value for acceleration. I can do that by finding out, by the same way I did it here. I know I have a value for initial velocity, I have a value for final velocity. I know distance is d and I need acceleration. So I'm actually going to do the exact same thing as I did right above. So I know final velocity is 0. This is VO. This is called d. So negative VO squared over 2d is acceleration. So friction force, I'm going to divide by the negative sign, by the way. Okay, so now I have friction force. And I don't know if you see, I can factor out a negative m. And I've got g sine theta minus VO squared over 2d. So that's my friction. That's going to go up here. Now I need an expression for normal force. So I need the y-axis. So that's Fn minus Fgy equals 0. It's not accelerating that way. So Fn equals mg cosine theta. So now when I put both of those together, I get mu equals the friction force, which is this, negative mg sine theta minus VO squared over 2d over mg cosine theta. And this m cancels with that one. Simplified, I get negative g sine theta plus VO squared over 2d, the whole thing divided by g cosine theta. So I ran out of room, that looks ugly. But it's not a pretty expression for sure, but it's a correct expression, and that's all that matters.